All right, folks, in this video, I'm going to go over the answer key to Solutions 5, Interpreting Solubility Curves. So on the left side of the screen here, I have the homework, and on the right side, I am showing the solubility curve. So remember that when I give a number, you can be plus or minus 2 from where I am and still be considered to be correct. So the first question is KNO3 at 30 degrees. I find 30 degrees. I go up to the KNO3 line, and to me it looks just a tad below 50 grams would be soluble in 100 grams of water. So I said 49. If you said 48, 49, 50, that's all acceptable. Same chemical, KNO3, but now at 70 degrees. So I find 70 degrees and go up to the KNO3 line, and I would say that's right about, I can dissolve 140 grams of KNO3 in 100 grams of water. So 138, 139, 140, all acceptable. For number 3, NaCl, how many grams to make a saturated solution? I make a saturated solution when I dissolve as much as I can. So the line tells me, the line for NaCl is how much can I dissolve, how much to make a saturated solution. So here's 100 degrees, take it up to the NaCl line, and it's just a little bit below 40. I would probably call that 38, 39, 40 grams per 100 grams to make a saturated solution. That is also the solubility at 100 degrees. Solubility of HCl at 50 degrees. So follow 50 up to the HCl line, and we get about 58, 57, 58, 59, something in that vicinity. At what temperature would you need 100 grams of water to dissolve 90 grams of NaNO3? So I got 100 grams of water, that's what we're based on. So I find 90 grams. So this is 90 grams per 100 grams. And I'm talking about NaNO3. So I go over to where 90 grams crosses the NaNO3 line, and I drop down, and it's somewhere in the vicinity of 22, 23, 24, maybe 25 degrees Celsius. Let's go a little further. Which substance appears to increase most in solubility as temperature increases? So we're looking for the one that has the steepest rise with temperature. Well, we have a whole bunch of them that are going up, but the one that's going up the most with temperature, it goes from about maybe 14 grams at 0 degrees up to 150 grams at 75 degrees. So I would say that KNO3 goes up the most. So our solids, sodium nitrate, potassium iodide, all our salts, seem that solubility seems to go up as the temperature goes up. Which one increases only slightly? So I'm looking for one that increases, but only slightly. Well, this almost looks like one of the grid lines. NaCl solubility changes very little with temperature. It's about 35 at 0 degrees and only goes up to maybe 38, 39 at 100 degrees. Which ones decrease in solubility? NH3, ammonia, HCl, SO2, and that is because those are gases. Now, we're used to seeing HCl in solution, hydrochloric acid in solution. But as a pure compound, it is actually a gas that gets dissolved in solution to make a solution of hydrochloric acid. Which substance is most soluble at 0? Which one can I put the most of in solution? Way up here, I can put about 126 or so grams of Ki into 100 grams of water. So I can actually dissolve more Ki. The solution will contain more Ki than water, but Ki will still be the solute that is dissolved in the water. Least soluble at 0, this one's the lowest amount, about 5 grams, is KClO3. Which substance is most soluble at 70? And it's kind of going to depend on how you look at this graph. At 70, Ki is already off the chart. So if you think about that, you'd probably say that Ki is most soluble. But if you look at what appears on the graph, the one that's still on the graph is KNO3 at about 139, 140 grams in 100 grams of water. Least soluble at 70, the one I can dissolve only a little bit of, less than 5 grams, is SO2. Which two have the same solubility at 73? The lines for HCl and KCl cross at about 50 grams is soluble at around 73 degrees. What is the difference between KNO3 and NaCl at 24 degrees? Well, 24 degrees, somewhere around here. KNO3 is about 40 grams. NaCl is about 35 grams. So the difference, we get a difference by subtracting. 40 minus 35, the difference is about 5 grams. Difference at those same two substances at 70 degrees. Well, NaCl, I can dissolve about 38. KNO3, I can dissolve around 140. So somewhere in the vicinity of 102, depending on exactly how you read the graph, might be 100, 103, 104. Number 18, saturated solution is made at 70 and cooled. So KCl at 70 degrees, I can dissolve about 49 grams. If I cool it and stir it, we're going to assume that it does not supersaturate. So if I cool it to 50 degrees, only about 42 is soluble. So if it does not supersaturate, that excess that is no longer soluble, that 7 grams roughly, I'm sorry, I'm at 70 degrees. That 7 grams roughly, no, 70 to 50, there we go. That difference of 7 grams roughly will fall to the bottom of the beaker. Number 19 asks whether various solutions are saturated, unsaturated, or supersaturated. A saturated solution holds as much as possible. So the solubility line for any substance represents a saturated solution. I have dissolved as much as I can. If I have dissolved less than I theoretically can, for instance, if I can dissolve 110, but I have only dissolved 80, I have dissolved less than I can. So that would be an unsaturated solution. If I have more than I should for a given temperature, that represents a supersaturated solution. So these are all in 100 grams of water. So for KCl, if I have 50 grams of KCl at 60 degrees, here's 60 degrees, I should be able to dissolve only about 56, but I have dissolved, I'm sorry, I should only be able to dissolve about 46, but I have dissolved 50, so I have more than I should have, so it is supersaturated. Sodium chloride at 10 degrees, I should be able to dissolve about 35. I have only dissolved 30, so I have less than the maximum, so it is unsaturated. For ammonium chloride, here's ammonium chloride at 100 degrees. I should be able to dissolve about 78. So that point falls just a little bit above the line at about 80 is a little bit above the line. So that one would be slightly supersaturated. If you called it saturated, that's pretty close. Sodium nitrate at 60. Sodium nitrate at 60, I should be able to dissolve about 124. but I have only dissolved about 100. So that is unsaturated. Ammonia, here's my ammonia line, 60 degrees. I should be able to dissolve about 24. I'm sorry, where am I? Sodium, we did sodium nitrate, my bad. Ammonia at 15 degrees, sorry. So ammonia at 15 degrees, I should be able to dissolve about 65, but I have only dissolved about 60, so that one would be unsaturated. Most NH4Cl that can be dissolved, same question, what's the solubility? NH4Cl at 70 is about 61 grams in 100 grams of water. Ammonium chloride at 45, about 48 grams, 47 grams. At what temperature could I dissolve 30 of KClO3? So I find 30, I go over to KClO3, and that temperature would be about 63, 64, 65 degrees. At 70, which can form the more concentrated solution, KNO3 or NH4Cl. If I look at 70 degrees, here's KNO3. I'm sorry, here's 70 degrees. Is it KNO3 or NH4Cl? NH4Cl, I can dissolve about 60. KNO3, I can dissolve about 140. So KNO3 would form the most concentrated solution. What temperature? 70 grams of water, NH4Cl, about 86 degrees. At what temperature? 70 grams of KNO3. 70 grams, go over to the KNO3 line, it's about 42 degrees. At what temperature? 65 grams of HCl. 65 grams over to the HCl line, somewhere around 35 degrees. Which would form the most concentrated solution at 20? Find 20 degrees. Well, SO2 is way down here. KCl is here. They're all kind of close, but at 20 degrees, the line for NH4Cl is above KNO3, it's above KCl, it's above SO2. How about 50 degrees? Well, here's SO2, here's KCl, here's NH4Cl, here's KNO3, so I can dissolve the most KNO3. If I make a saturated solution of ammonia at 10 degrees, I can dissolve about 72 grams of ammonia. If I heat that solution, the solubility of ammonia actually decreases. So at 50 degrees, it's only about 30 grams. So 72 minus 30 is a difference of 42. So that ammonia would actually get released from the solution into the air, and you would get a strong ammonia odor. Okay, if I take 61 grams of ammonium chloride at 70 degrees, ammonium chloride, 61 grams at 70 degrees is pretty much right on the line. And that was my intention. If it's that close to the line, we can debate, is it 60? Is it 60 and a half? Is it 61? But when it's that close, I'm meaning for it to be interpreted as a saturated solution. So that's your answer key. Hopefully you were getting most of those correct as you did the homework.